intersection of algebra and counting and sometimes even probabilities is this idea of combinations of different objects. So before studying combinatorics or combinations, we need to first define factorials. So factorials is an operation where you're going to use the exclamation mark to denote the factorial, and basically what it means is that you are going to multiply all the numbers starting from the number you see until 1. So sounds complicated, but it's actually easy. So 3 factorial is basically 3 times 2 times 1. That's it. So 3 factorial is actually equal to 6. And you could do the same thing here. 4 factorial is 4 times 3 times 2 times 1. So that's going to give you a 24. And then the same thing with 12 factorial, 12 times 11 times 10 times, and so on until you get to 2 times 1. And that's actually going to be a very big number. So you can find the factorial symbol on the normal scientific calculator, and it's going to be one of the shift buttons. But in here, I'm going to write 12, and then I'm going to go to math. Without the second, you're just going to go to math and go all the way to probability, because combinatorics and factorials fall under probability. And you're going to click this option. Press enter, and that's the number we got. So one thing to note is 0 factorial and 1 factorial are special cases. They're both equal to 1. So that's something you have to remember. Why is it equal to 1? It doesn't seem like we're multiplying with anything. That's something you could research on your own. But 0 factorial is 1, and 1 factorial is 1. So this is what the factorials is, and you can use this in something called permutation, but for AASL, permutations are not included. But we will use them in something called combinations. So let's look at this question. In how many ways can you pick 2 letters A, B, C where the order does not matter? So this is called combination. So you're looking at a combination of these 3 letters. So you're picking 2 out of these 3 letters, but the order doesn't matter. So I could do AB, which is the same thing as BA, so I'm not going to write BA, AC, and then BC. So in total, I have 3 options. Now, this is easy to do with a small number of letters. What if I have like 20 letters, and I need to choose a combination of 2 of them, or maybe 4 of them. So in this case, we're going to have so many different options. So what we use is something called combinations. So this is where we have a specific formula that could tell us all the possible combinations of such an example, where order does not matter. So the idea is that N represents the total number of objects, and the R represents how many you are choosing. Okay, so for this example, we have 3 letters, and we're choosing 2 letters. So we want to order 2 letters out of those 3. So the N in this case is 3, the R is 2, and we call this 3 choose 2. And the C symbol here can be represented as choose or can be represented as combinatorics. And this is the formula that would give you the total number of combinations. So if I apply it to this example, I'll have 3 factorial divided by 2 factorial, and then N minus R will just be 3 minus 2 factorial, so that's just going to be 1 factorial. You can use the formula on your own, but we can also use the calculator for this. And my N is 3 and my R is 2 in this case, so I'm going to go 3 choose 2, and then using the calculator, I'm going to write 3, go to math, go to probability, and then pick NCR, and then pick my R as 2. Press enter, and that's going to give me 3. So if you simplified the formula, it should give you 3. So that means that if I pick 2 letters out of these 3, I should have 3 different combinations. So let's look at some examples. So the formula is here at the top, so you can see the substitution I'm going through. And these are the different ways we can write combinatorics. So the n could be at the bottom, the n could be at the top. It could be represented as this matrix or like this column vector type thing. So n goes at the top, r goes at the bottom, n at the top, r at the bottom, and so on. So these are different ways of representing the same thing. So for the first one, we're just going to substitute our n and our r. And always has to be bigger. Obviously, you can't pick a set of, you can't have 2 letters and then you have to choose 5 from those letters. You can't. So we're going to substitute all the things in there, multiply out 4 times 3 times 2 times 1. The denominator will be 2 times 1, 2 times 1, and that's going to give us 6. So there are 6 different ways of picking 2 items from a set of 4 items. What about the other one? I'm using a trick here. So it's 6 factorial divided by 5 factorial multiplied by 6 minus 5 factorial. I'm simplifying it, but what I'm doing in the numerator, I'm not writing it all out. What I'm going to do is do 6 times 5, and I'm going to stop there. And then everything else, like the 5 times 4 times 3 times 2 times 1, is represented inside this factorial. So we're stopping at the 5 factorial. So this is a very good trick to use because I can now cancel out the 5. So you can multiply it out if you want to and divide by 5 factorial, but if it's like a non-calculator paper, this is a trick you could use. I'll use the trick again in another example. So for 3 factorial, I'm going to put it out, and the denominator will have 0 factorial, which we know is equal to 1. So again, you have to remember this fact. 3 factorial divided by 3 factorial is just 1. And the last one, again, I'm using the same trick, 5 factorial, and then the denominator will have 3 factorial and 2 factorial. So again, I'm going to undo the factorial here. So I'm going to go 5 times 4 times, I'm going to stop at 3 factorial, because that's going to help me cancel out the 3 with the denominator. So you can do that. You can stop at a number and not lay out all the values. And then 2 factorial is just 2. 5 times 4 is 20, so then I get a 10. So this is much easier than actually calculating 5 factorial and dividing it by whatever the denominator is going to be. So it's an easier method. These are some of the properties you should know of factorials, is that if you take the same number, so n choose n, so if I have 3 letters and I'm picking 3, how many ways can I do that? It's only 1 way. If I have 3 letters, I'm picking none, how many ways can I do that? It's just 1. So again, and we saw this example here, 3 choose 3 is basically just equal to 1. So these are facts that would help you. You don't have to remember them, but they would help. And then n choose 1 is equal to n, and then n choose the previous number is equal to n. So for example, we saw it's here, so 6 choose 5, 5 is 1 less than our n, so 6 choose 5, that's just going to be equal to 6. So for example, if you had 12 choose 11, that's going to be equal to 12, and if you had 12 choose 1, that's going to be equal to 12. Factorials show up in something called a Pascal triangle. So you can pause the video, look for a few seconds at this video, and try to see what relationship this triangle has with what we've done. In more detail, we can look at Pascal's triangle and we can see different things. Specifically, we can represent each row by the letter n, and each position, so first, second, third, fourth, could be represented by r. But we start with 0 and then go all the way up. So let's take the 4th row, for example. So the 4th row in Pascal's triangle, my n is going to be equal to 4. And then the r is going to start from 0 and go all the way up to 4. So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. And basically what this tells you is, for example, if I have 4 choose 2, that's going to be equal to 6. And if I have 4 choose 3, that's going to be equal to 4. So one of the things you'd notice is how the endings are always 1. And that's represented by the fact that r is equal to 0 or r is equal to the n itself, which is a property I showed on the previous slide. You'd also notice that the next value after 1 is always the n itself. So this was represented by the choose 1 and then choose the n minus 1. Another thing to notice is that a value in one row can happen from adding the previous two rows. So 10 comes from adding 6 and 4, and the 3 comes from adding 2 and 1 on the previous row. So that's a property you would note. Again, not something you would memorize, but it is a helpful fact, especially if you're doing a lot of combinatorics and you are trying to find some of the values. Also notice that it's symmetrical, so the values will kind of repeat after the middle part. So these are all the facts about combinatorics, about factorials. It's important that you just know how to use the combinatorics formula, and then the link with Pascal's triangle is an additional thing that will be useful for binomial expansions and so on.